Welcome to the NJIT website and math podcast. My name is Vanessa. Today I will be covering expressions and domains. So let's first go over some important terminology that's necessary. What is involved in expressions, or as we can also call them, algebraic expressions? Well, expressions are made up of terms. A term can be any number, it could be a constant, a variable, a group of these in parentheses, or any combination of this is what we consider a term. And terms can be brought together with using different operations such as addition, subtraction, multiplication, and division. And you can also bring in with exponents, roots, natural logs. Any combination of these can be considered the making of an expression. So when you have these expressions in any form, and then let's say you put a value in for the variables, you would use the order of operations to address this expression and condense it down to a single value. That's what's called the value of an algebraic expression. So because they come in many forms, let's just go briefly over some examples of what this could look like. You can have something as simple as x minus 2. You can have something with the fraction 1 over x plus square root of 7. There you have a root in a fraction with our variable of x. Here you have 10 over y plus 3. In this case, our variable is y, and we have constants of 10 and a fraction. Or you can have it we can have more than one variable in an expression. Like here, we have root of x plus the double bar represents absolute value of y, and then divided by 5. So then when you have several operations, you would think to yourself, say you have addition, you have subtraction, you have all these things going on in an expression. Where do you start? How do you solve it? Well, in the algebraic expression thinking, you have what's called PEMDAS. And PEMDAS is the order of operations that is recognized as the proper way to address an expression. Now, if you don't know what the acronym for PEMDAS is, that would be P-E-M-D-A-S. PEMDAS. That stands for parentheses, exponents, multiplication, division, addition, subtraction. And this is the order that you have to do any expression in. So if there's parentheses, you do parentheses first. Exponents, multiplication, division, addition, subtraction. So whatever the highest order is, that's how you have to address it. Because if you were to switch up this order of operations, you have the possibility of getting a very, very different answer, which in recognizing, it would be the incorrect answer. So we'll go over a few examples and you'll get the feel for it. So let's start by doing something relatively simple by getting the value of an expression. So let's say we had the absolute value of x minus 2 over y under the condition that x would be equal to 2 and y is equal to negative 2. Now what you would just simply do here is you would replace x with 2 and y with negative 2. So let's see what we get. So we have absolute value of 2 minus 2 over negative 2. Now let's go over our PEMDAS. PEMDAS, first we have parentheses. Now technically you can consider absolute value as a form of parentheses with the double bars on both sides. And then pretty much what absolute value means is that whatever the expression of the number is, you need to make sure it's the positive version. So since the 2 is already positive, we don't have to do anything to it, so we can pretty much just rewrite it as a 2. And then let me just rewrite the rest here. Okay, so we don't have any exponents. We don't have any multiplication, but we do have division. right here over the 2 divided by a negative 2. So we have to do that. We have to do that next. So the 2 divided by negative 2 is negative 1. So, and if it helps, use parentheses in this case because you have the double negative here. So this becomes 2 divided by negative 2, which is negative 1. Alright, so then now we want to address this double negative going on here. So a minus negative 1 is just the opposite, turns it into a positive 1. So this just gives us 2 plus 1. And then finally, our last step would be addition, naturally. So then our final answer would be 3. Right? Very good. So let's try something a little more complicated with more order of operations. Let's say we have this big bracket here, and then we're going to have 9 plus x in this set of parentheses divided by 7. And then we're going to close the big bracket. The dot can symbolize multiplication, so it'll be times 3, and then minus x. Okay. And then our condition is that x is equal to 5. Alright, so first thing we want to do is we want to substitute the 5 in for x. So let's do that. Aside from that, keep everything else the same. So we have 9 plus 5, close parentheses, divided by 7. I'm going to close that bracket, times 3 minus 5. Okay. Alrighty, so now we see that in order of operations, our first step would be to do parentheses. Note here that we have 2 sets of parentheses. So now what do you do? So the rule of thumb is when you have multiple sets of parentheses, you go from the inside and you work your way out. Okay, so let's do that first. Our inner parentheses is we have the 9 plus 5, so we need to address that first. So let's do that. So here we have 9 plus 5, which is 14. And then if you're not used to doing this, I would do it step by step. So then once you do one operation, you would rewrite the rest and go on to the next step. So now we just have one set of parentheses, and now we do this one. 14 divided by 7, which is 2. And then rewrite the rest. And then next in the order of operations would be the multiplication, correct? So then the 2 times 3, which would be 6. We have minus 5 left. And then finally subtraction. 6 minus 5 is, 1. So our final answer would be 1. So that's so then, the order of operations can get much more complicated than that, much more complex, but again, the process is exactly the same. As long as you follow the order of operations step by step, you can very simply get the value of the algebraic expression. So let's switch gears here real quick, and now we're going to start to talk about domains. What is a domain? The domain of an expression is simply a range of values. A range of values because there are only for some expressions, there are only a certain number of values that you can put in without getting an undefined. And an undefined is simply a value that does not fit into the function. If you were to take an expression and say draw it on a piece of graph paper, if you start drawing on a piece of graph paper and you are required after you start drawing it to take your pen off the paper to a different location, then that means that there's a spot on that expression where there's a break and there's a value that just can't exist. That value would not exist in the domain. So the domain is simply a list of the possible values that can fit into the expression. So let me just do a quick easy example of that. Say if we had the expression 1 over x minus 1. Okay, this is your typical expression. what is the domain of this expression? Now, the way I like to look at it is that, the number line is huge. It can go from negative infinity over to positive infinity, which leaves a lot of room. So the way I like to look at it is not so much what is the domain, but what doesn't go in the domain. Because chances are it's easier to pinpoint what doesn't fit as opposed to what does fit, which is essentially all the other numbers in the universe. So let's look at this. Here we have simply a fraction, 1 over x divided x minus 1. Okay? Now, one of the rules of a domain is that you cannot have a 0 in the denominator, because if you have any constant over 0, that's immediately considered undefined and doesn't work. Okay? So, if we can't have a 0 in the denominator, that means that whatever value that is put in for x can't cause the denominator to be 0. So the way that you can write this out is that x minus 1 cannot be 0, right? Because that's what we just said. Because if x minus 1 becomes 0, then the whole thing becomes undefined. So then if we solve for x by adding 1, we simply get that x can't be 1. And apart from that, there's no other restrictions on this expression. So basically, 1 is the only value out of the whole spectrum that is not allowed in the domain. So that means that our domain is all numbers except for 1. All real numbers except for 1. So before I go on to another example, let me just outline a couple of rules for domains, just stuff that you have to remember. Because if you have a long expression with no fractions, no natural logs, no roots, then pretty much it can be all real numbers. But the special things to look out for are, I'll write it down, number 1 is fractions. As I just did in the previous example, with fractions, the denominator cannot be 0. So the easiest way to do it is to take your denominator, set it equal to 0, and then that will be able to give you the values that it can't be, and then pretty much it can be all other values. The second one to look out for is roots, square roots to be more specific, square roots. With square roots, the inside of the root cannot be equal to 0. Cannot be equal to anything that's negative. It can be 0, it can be positive, but it can't be negative. So basically, instead of writing your expression is not equal to 0, you would simply address your expression to be less than 0. And then you would solve for the variable, and then that would tell you what expressions cannot work. And then the other one to look for would be logs. Now, logs usually you're represented by a log, or more appropriately by the natural log. And with natural logs, you cannot have 0 or negative. So it would be, you would set your expression less than or equal to 0, because you can't have a natural log that's equal to 0 or a natural log that is negative. Alright, so those are the things to look out for. So now we'll just do a bunch of expressions. Before I actually do that, the notation is also very important, because once you figure out what the values can't be or can be, how do you express it? Well, you have a couple of different choices. You can either express it simply like I did. Your domain is all real numbers except for 1 in this previous example. So what would you write? You can write all real numbers except x equal to 1. You can write it out like that. Or the symbol for all real numbers is the R with an extra little bar on it. Except x x equal to 1. Or if you want to write it in what's called interval notation, you can write it this way. Because the number can be any number from negative infinity to infinity besides 1, what you can do is you can write negative infinity to 1 union 1 to infinity. Let me rewrite that over here so you can actually see it better. Okay. Now what this means is, pretty much, is that the range of values is from negative infinity to 1. And because it's a parentheses, that means that the 1 is not included, which simplifies that 1 is not part of the domain. And then there's a union, and then here's the other side of the range, which is 1 all the way up to infinity. So here pretty much you have 3 ways of writing it. And that's how you would symbolize the domain of an expression. So now let's go into some actual examples. Okay, so say we have a very simple expression like x plus 2 over x. Here we have another fraction. So in the numerator, we don't have any roots, we don't have any natural logs, or any fractions in the numerator. So the x in the numerator can be any single number, all real numbers. What we have to worry about is the x in the denominator, because as I said before with fractions, x cannot be 0. X can be negative or x can be positive, but it cannot be 0. So as I said before, the best thing to do is to write on the side, is to take your expression in the denominator and write the condition of the values that it cannot be. So in this case, x cannot be 0. So, and luckily here, normally you would have to solve for x, but here we don't have to do that. It's already solved. And we know that here, we can base this off from here. The answer is that x can be any real number except for 0. And then just for fun, let's just write it in interval notation. That means that it can be from negative infinity to 0, parentheses, union, and then we're going from 0 to infinity. And then that will be our domain for that expression. Okay, so let's take it up a notch and we'll do a different one. Let's say we'll do another fraction, but with a little bit different. Say we had this 5 over, sorry about that, x squared plus 1. Here we have a fraction, but it's not just an x, it's an x squared. But again, it starts off exactly the same way. The denominator cannot be 0. So let's rewrite let's do what we always do. X squared plus 1 cannot be 0. So what we have to do now is solve for x. So x squared, and we need to move the 1 to the other side, so we subtract 1. That gives us a negative 1. And now how you get rid of the squared? The squared, you would do the opposite, which is doing a square root. So you do the square root, square root. Note, you can't take the square root of a negative number. So what does that mean? That there's no values to satisfy this expression. Which makes sense, because let's go back to our original problem. Any number that you were to put into x, because it's squared, it's going to come out positive no matter what. You can put any number, negative or positive, in there. It's always going to be positive, and just adding 1, which means that any number you put in here is going to be able to satisfy this expression. So the proper way to write this out would be, the answer would be all real numbers, correct? No exceptions. So you can either write it with the r with the double bar, or if you want to write in interval notation, there's no breaks in the interval, so it would be just from negative infinity to infinity, right? And then that will be it. So now we're going to do something a little bit different. Let's try this example. 7 over x minus 1 times x plus 2. Okay? Same thing, we got a fraction. The denominator cannot be negative, but we have two terms here, x minus 1 and x plus 2. Naturally, it has to satisfy both those parentheses, because if one of the terms comes out to be 0, it's going to make the whole denominator 0, which makes the whole expression undefined. So here we have to actually do a little bit more work. We have to do x minus 1 cannot equal 0, and x plus 2 also cannot be 0. And if you solve those, x cannot be 1, and x cannot be negative 2. Right? Okay, so that means that the expression the domain of the expression is all numbers except for negative 2 and 1. So what if we were to try to write that in interval notation? What would it look like? We're going to have, in this case, we're going to have 3 intervals, where it's going to go from negative infinity to negative 2. Then we're going to have a union between negative 2 and 1. And then we're going to have another union from 1 to infinity. Right? Because we have 2 breaks in the domain at negative 2 and 1, but it can be any number in between, which is why we have 3 intervals. Alright, and now we're going to do one more example, having separate terms. So let's say if we had the expressions 5 over x minus 3 plus 4 over 3 minus x. Alright, so now you have 2 separate terms here, completely separating each other, brought together by addition, and they're both fractions, which means in each of these terms, the denominators cannot be 0. So you have the best way to do it is, initially you would think, oh, I need to bring them together and do a common denominator, but that's really not the case. If you were to do the same thing, the same way we did with the previous example, and just do the denominator separately, with the terms separately, then you should be fine. Because if you think about it, if one term is undefined, then that pretty much makes the whole expression undefined as well. So you can do them separately, which is what we're going to do right now. So let's do that. X minus 3 can't be 0, as well as 3 minus x cannot be 0. Okay, and if we solve those, that means x cannot be 3. And then this other one, and if you move it over, that pretty much gives us 3 cannot be equal to x. So essentially, we actually do get the same. We get the same answer for both sides. So in general, that means our only domain that we have to worry about is 3. So if we do that, if we write that in interval notation, what does that give us? That gives us negative infinity to 3, union 3 to infinity. And that's all that is. So don't be afraid if the terms are separate or together in under one fraction. If you do them separately, it should be much easier. So thanks for visiting the NJIT website Math Podcast. If you need any further assistance, stop by the Center for Academic and Professional Enrichment, also known as the CAPE, over in Kupfrian Hall, room 200. So good luck in your studies.